Hello Lightning Leaders, and welcome back to a series of math videos. In the last one we talked about geometry in the terms of lines. Today we're going to do more geometry, but today we're going to talk about angles. So there's four angles we talked about in this unit: an acute angle, an obtuse angle, a right angle, and a straight angle. Now, just like with the lines video, geometry is such a different kind of math. It's not so much numbers and computations like with algebra. With geometry, it's more definitions. You have to learn what each of the terms are to be able to do the math, which is kind of the trickiest thing about geometry, because it's the most reading you're going to be doing in math. But this is why we practice all those vocabulary skills in ELA, because it's more than just reading. You're going to need these vocabulary skills in. We need them in math too. So I'm going to go through each one of these angles one at a time, how to define them and what they look like. And then what I'm going to do is I'm going to put a cut in the video and I'm going to draw a picture up here on the board. And what we're going to do is we're going to determine the size of those angles using what we know from these definitions. And then I'm going to put another cut in. I'm going to put a different picture up there. And it's going to be your job to tell me the size of the missing angles. So I'm going to go through the definitions here. We're going to do one example together, and then I'm going to leave you with an example to try on your own. So with that said, let's jump right in. Our first angle is an acute angle. And these angles are small angles. These angles are less than 90 degrees. So these angles are less than 90 degrees. Now, that means that these angles kind of look like our greater than and less than symbols. These angles are small. So for example, this one, I don't have my protractor, I left it in the classroom. We'll say this angle is 45 degrees, because that's less than 90. These angles are cute, they're tiny. So that's one way you can remember that the acute angle is the one that's smaller than 90, because it's got the word cute in there. Now, our next angle is the obtuse angle. These angles are greater than 90 degrees. These angles are greater than 90 degrees. These angles are huge. Now, one way to remember this one is, one way of saying a person is really big is saying they're obese, starts with an O. Obtuse, big angle. Obese, big person. Obtuse, big angle. These things are huge. These angles are much bigger than 90 degrees. And they look something like this. Our next angle is a right angle. Now these angles are perfect corners. Remember, we had our right angle tool in class. We had that index card because the corners are perfect 90-degree angles. And we used it to help us determine if an angle was right, acute, or obtuse. These angles are equal to 90 degrees. These are perfect corners, and they're always labeled with this little square on the angle. That's how you know an angle is a right angle, because it's got this little square on it. Now there's one more angle we talked about, and that is the straight angle. These angles are equal to 180 degrees. These angles are straight lines. Every single line is a straight angle, 180 degrees. Now, one other thing we should keep in mind is how many degrees it takes to go around a full circle, and that is 360 degrees. Because if we look here, this is half a circle. 180 plus 180 is 360, and that would be all the way around. So to recap our angles, we have the acute angle, which is less than 90 degrees, and they look like this. They're small, they're cute. We have our obtuse angles that are greater than 90 degrees. These are the big ones. They're obese. They're fat angles. Then we have our right angle, which is equal to 90 degrees. It's exactly 90 degrees, no more, no less. The only way an angle can be a right angle is if it's equal to 90 degrees. And then our last angle is the straight angle. These angles are exactly 180 degrees, no more, no less. And they are straight lines. Every single straight line is a straight angle. What I'm going to do now is I'm going to erase this chart, and I'm going to put up a whole bunch of lines on here. And we're going to have to try to figure out the measurement of the angles missing in the picture. So I'm going to put a cut in the video, and when I bring you back in, we'll do the example problem. Be right back. All right, Lightning Leaders, welcome back. So I have this picture up here on the board, and it's going to be our job to find the missing angles. Now, they only gave us one angle on this picture, but believe it or not, we can actually figure out the other three. So our job is going to be to figure out the measurement of angle FJG. We also need to figure out angle GJH. And we need to find angle HJK. Now remember, our symbol for angle is the little like less than symbol with the arc through it. And whenever we go to name our angles, the point that's in the middle, where the two lines meet, that letter is always going to go in the middle of naming our angles. And then the ones on the outside go on the outside. That's why this angle right here, here's F, here's J, and here's G. This angle right here is FJG. We follow the points in order, where this point in the middle, where the two, looks like these points are rays, so where the two rays meet is the middle of our angle. Now, FJG is a pretty nice one. FJG, we've got a little square here, which means that angle FJG is 90 degrees. Well, that wasn't too bad. Now, let's start moving around here and see if we can figure out the other ones. Oh. Well, FH is a straight line. You see that? It's a straight line. This just happens to go through this point here. We know that straight lines are 180 degrees. So, if straight lines are 180 degrees, that means this whole... I'm going to change my color here. Let's see. What's the color I have? I'm not using the light green. If FH is a straight angle, that means this whole thing here in green is 180 degrees. The whole thing is 180 degrees. But if this little part here is 90, that means I can just do some subtraction to figure out how much is left. Because I have a whole, I have a part, and I need to find out the missing part. So let's do some subtraction here, because that's going to give us the answer to what GJH is. So let's see, we're measuring in degrees. I'm going to bring down my degree symbol. 0 minus 0 is 0. All right, 8 minus 9. It's got to be 1, right? I can hear half of you screaming at me right now. It's not. This number up here is smaller, so I can't take it away. I only have 8 things. I can't take 9 from that. I'm missing some. So I need to go over to the hundreds place, take one of those hundreds, and there's only one there, so now there's nothing here anymore. Bring that 100 back to the tens, which means I now have 10 more tens, because 10 times 10 is 100, so I have 10 tens added to the 8 tens that are already there. So now I have 18. 18 minus 9 is 9. So now I know that angle GJH is also 90 degrees. Now I have one more angle to figure out here, and that's angle HJK. Now, again, we know that line FH is a straight line. So we know that since FH is a straight line, that I'm going to use the color, let's use the light blue because we didn't use the light blue, which means that this whole piece here is 180 degrees. So now I just do the same thing again. If the whole thing is 180 degrees, I just need to do 180, because that's my whole, 180, and then I need to subtract the part that I have. This time I only have 48. And that will give me the answer for how much angle HJK is. So let's do some math here. I can't take 8 things from nothing. That's not possible. So I need to do some borrowing here. 10 minus 8 is 2. 7 minus 4 is 3. 1 minus nothing is 1. So now I know that angle HJK is 132 degrees. So now I found how much each angle is. And now just to check to make sure my angles make sense, this is definitely an obtuse angle. Look how big this is. 132 is more than 90. So that makes sense. We found an obtuse angle, we have an obtuse measurement. This angle is small. They already told us it was 48, so we already know it's an acute angle. Now, the square here helped us figure out that this was 90. And they threw this little arc in there to trick us, to try to throw us off. But we're mathematicians. We're smart. We know this stuff. We knew that the whole line was 180, and if we took the part that we already knew out, we were going to end up with the part that we needed, which happened to also be 90 degrees. So this angle here is really a right angle. All right. What I'm going to do now is I'm going to erase this, put another cut in the video, and when the video comes back, there's going to be a new picture up here. And it's going to be your job to find the missing angles. All right? I'll be right back. All right, Lightning Leaders, here is the example problem I have for you. What I have for you here is they gave you these two angles, angle QRV and angle VRT. And what I want you to try to figure out is the other 3 missing angles, angle QRP, angle TRS, and angle PRS. I want you to try to figure out the measurements of those 3 angles. Now, the beauty of having this all in a video is that if you get stuck at any point and you can't remember how big a straight angle is or a right angle or any of that, you can just back up this video and listen to me talk all over again. Because everything we've talked about so far is what you need to figure this, to figure out these missing angles. So if this is the video you choose to respond to, you get to choose how you send your answers to me. You can write it on a piece of paper, take a picture of it, send it to me. You can type your answers up in a Google Doc and send it through Google Classroom or through an email or however you find it easiest to send it to me. That is okay. All right, so go ahead, try to figure this out, and I'll see you next time for our next math video, which I haven't figured out what we're going to do yet. So we'll find out together. Bye now.